Hi there and welcome to our next video on multiples, factors and prime factors. In this video we're going to be looking at the definitions of each of these topics, some examples, prime numbers and different methods we can use to find out the prime factors. So first of all, factors and multiples. Here are the exact definitions. The multiples of a number is just its times tables. So if we say the multiples of 8, we would have the 8 times tables. And the factors of the numbers are all the numbers that divide into it. So if we said factors of 24, it would be all the numbers that divide into 24. And some examples, so we might be asked to find the first 8 multiples of 13. So we would have 13, 26, 39 and so on. And we could also be asked to list the factors of 24. So all the numbers that go into 24. The easiest way to do this would be to draw a circle with 24 in it. Does it go into the 1 times table? Yes it does, 1 and 24. 2 times table? Yes it does, 2 and 12. The 3 times table? 3 and 8. 4 times table? 4 and 6. 5 times tables? No, we've got the 6. 7? No, we've got the 8. So these would be the factors of 24. Okay, now moving on to prime numbers, we have the exact definition over here. A prime number is a number which doesn't divide by anything apart from itself and 1, i.e. its only factors are itself and 1. The only exception is 1, which is not a prime number. So there's always confusions around that 1 is a prime number, but it's not, because a prime number doesn't divide by anything except itself and 1. So the factors of it has to be the number and 1. If we have 1 as a prime number, then it's divisible by 1, but 1 and 1 is the same number. So this is why it's not classified as a prime number. Over here we have the first 8 prime numbers up to 20. We have 2, 3, 5, 7, 11, 13, 17 and 19. These are all prime numbers. They only divide by themselves and 1. The only thing I'm going to talk about here is 2. 2 is a very special prime number because it's the only even prime number that there is. Because every other even number goes into the 2 times table itself except 2. 2 is an even number. It goes into the 2 times table and 1. It's only divisible by itself and 1. Now moving on to prime factors. Any number can be broken down into a string of prime factors. So let's say 24 over here. We have two ways of calculating the prime factors of 24. Let's call this method 1 and method 2. Method 1, both of them are the same. So both of them split 24 into two sets of numbers. So when we've worked out the factors of 24, let's go back to that slide. Over here we have the factors of 24. The factors are 1, 2, 3, 4, 6, 8, 12 and 24. These are the factors of 24. So you can split them into whatever you want. So if you go back over here, method 1, they split them into 4 and 6. Method 2, they split into 3 and 8. So if we do another method 3 over here, we can split 24 into maybe 2 and 12. Now the next thing that we see, can these numbers be split even further? 2, can 2 be split any further? No, it can't, because 2 is a prime number itself. So we circle all the prime numbers. So let's circle 2. Can 12 be split further? Yes, it can. So let's think of it. 2 and 6, it can be split into 2 and 6. So let's write down there. Can 2 be split further? No, it can't. It's a prime number. Let's circle it. Can 6 be split further? Yes, it can. It can be split into 2 and 3. Can 2 be split? No, it can't. It's a prime number. Can 3 be split? No, it can't. It's a prime number. So now we have all our prime numbers. Now all we need to do is just write them out. So our prime factors of 24 are 2 times 2 times 2 times 3. And you can see that whether we use method 1, 3 or 2, we always come to the same conclusion. Over here we have three twos and 1 3. Over here we have 3 2s and 1 3 as well. We always come to the same conclusion. Now we have this array of prime factors. We need to simplify this, so we need to write our answer in index form. It's always important that we do this, and you could potentially score more marks if you write your answer in index form. So let's see how many times the 2 is repeating. So let's write down 2 first. How many times is the number 2 repeating? It is repeating 3 times, so we write a small 3 at the top, multiplied by, there's a 3 over here, so let's write 3. How many times is 3 repeating? It's repeating once, so we can just leave it like that. So our index form would be 2 cubed multiplied by 3. And I'm going to teach you another way of working out the prime factors of 24. So we have 24 over here. We have an upside down bus stop. So we have 24 and we have our prime numbers over here. So 2, 3, 5, 7, 11, 13, 17 and 19. It's always good to memorize these numbers as they could help you in exams. So we have 24. What is the lowest prime number that 24 goes into? So let's start off with 2. Does 24 go into 2? Yes, it does. So let's write 2 on this side. So 24 goes into 2 12 times. So does 12 go into 2 again? Yes, it does. So we can use 2 again. Now we have 6 left. Does 6 go into 2? Yes, it does. It still goes into 2. So let's divide it by 2 again. We have 3. Does 3 go into 2? Unfortunately, it doesn't. So we need to get the next lowest prime number. Does 3 go into 3? Yes, it does. So we can divide by 3 all the way until we come to 1. And now once we've come to 1, all of these are our prime factors. So we would write them out as 2 multiplied by 2 multiplied by 2 multiplied by 3. And as you can see, that is the same as what we worked out using these factor trees. Writing this in index form would be 2 cubed multiplied by 3, and that would be our final answer. In the description box below, there's a link to a quiz which you can have a go at. In our next video, we're going to be looking at some exam questions relating to multiples, factors and prime factors. But for now, that is it for this video. Thanks for watching. I hope you liked it. And one last thing, please subscribe, hit the like button and the notification bell.